In this video, I'm going to demonstrate the effect of angle and phase on U-joint. This is also known as the pinion angle in automobile world. In this demonstration, I use the constant speed electric drive unit. The drive unit rotates a drive shaft consisted of two U-joints, which is similar to what is used in many cars. As you see in this arrangement, because all the U-joints are in the straight position, you can see and hear all the plates are rotating at a constant speed and in sync with each other, no matter what phase they are in. Let's set up one of the U-joints at an angle. As you see and hear, the left side plate, which is located after the U-joint operating at an angle, is not rotating at a constant speed. This can stress out a drive unit and introduce vibration to the system. One easy way to avoid this is by using a proper phase and angle on a second U-joint to cancel out this effect on the input and output plate. However, the plate in the middle will not rotate at a constant speed, as you can see and hear. This is also known as destructive interference in physics. In such configurations, the importance of the correct phase of the U-joints relative to each other should be noted. As you can see in this example, not only the consistency and vibration didn't cancel out, but it actually doubled. This is also known as constructive interference in physics. Hey, if you enjoyed watching this video, please like, share, and subscribe to my channel. See you on the next.